In 2023, a lawyer used ChatGPT to write a legal brief. ChatGPT invented 6 court cases that didn't exist. The lawyer filed it anyway. He got sanctioned, fined, and became a national punchline. But here's what nobody talks about: ChatGPT didn't lie. It physically cannot lie. Lying requires knowing the truth and choosing to say otherwise. ChatGPT doesn't know what's true. It only knows what words tend to follow other words. It has read the entire internet, but it has no way to check its own work. So how do you fix that? How do you turn a model that confidently hallucinates into one that cites real sources? The answer is Retrieval-Augmented Generation, or RAG, and it's the most practical idea in AI right now. By the end of this video, you'll understand exactly how RAG works, and you'll know how to build one yourself. Why do language models hallucinate? It's not because they're broken. It's because of what they fundamentally are. A language model is a prediction machine. It takes the words you've given it and predicts the most likely next word, then the next, then the next. It has no database to query, no search engine to consult, and no internal fact-checker. Everything it knows was compressed into its weights during training, and that compression is lossy. Imagine reading 10,000 books and then trying to answer questions purely from memory. You'd get a lot right, but you'd also confidently misremember things, mash up different sources, and fill in gaps with things that sound plausible. That's exactly what happens inside a language model. The model is not accessing facts. It is accessing probabilities. And probability doesn't care whether something is true, only whether it sounds like the training data. So how do you give a model access to real facts? The answer is deceptively simple: don't ask it to know things. Give it a search engine instead. That's RAG. Retrieval-Augmented Generation. 2 steps: retrieve, then generate. First, you take the user's question and search through your own documents. These could be PDFs, company policies, product manuals, scientific papers, anything. You find the most relevant chunks of text. Then, you take those chunks and you inject them directly into the prompt, right above the question, like giving the model a cheat sheet before the exam. The model reads the retrieved documents, sees the answer right there in front of it, and generates a response grounded in real sources. It's not memorizing. It's not guessing. It's reading. But how do you search through documents for meaning, not just keywords? That's where embeddings come in. An embedding is a list of numbers that represents what a piece of text means. 2 sentences with similar meanings get similar numbers. 2 sentences about different topics get very different numbers. Think of it like a map where every concept has coordinates. The sentence, "How do I reset my password?" and the sentence, "I forgot my login," end up close together on this map, even though they share almost no words. To compare any 2 pieces of text, you compute the distance between their embeddings, usually cosine similarity. This is the engine underneath every modern search system. It's how Spotify finds songs you'll like, how YouTube recommends your next video, and how RAG finds the right document chunks for your question. Once you can turn text into numbers, you need a place to store and search millions of them. That's the vector database. Here's how it works. You take all your documents, say, your company's entire knowledge base, and you split them into chunks. Each chunk is maybe a paragraph, maybe a few sentences. Then you run each chunk through an embedding model, producing a vector for every single chunk. Store all of those vectors in a database optimized for similarity search. When a user asks a question, you embed their question into a vector too. Then you search the database, find the top 3, or top 5, or top 10 most similar chunks. This all happens in milliseconds, even with millions of documents. The search result is not documents that contain the word password, it's chunks that are semantically about account access and security. Let's walk through a complete RAG pipeline end to end. A user types, "What's our return policy for international orders?" Step 1, the question gets embedded into a vector. Step 2, that vector searches your company's document database. Step 3, the database returns the 3 most relevant chunks: your shipping policy, your returns FAQ, and your international terms of service. Step 4, those 3 chunks get injected into the prompt, right above the user's question. Step 5, the language model reads everything and generates a precise answer, citing your actual policies. The user gets a correct response, and the model never had to memorize your return policy. It was never in the training data. It never needed to be. The model didn't learn anything new. It was just given the right context at the right time. That's the entire idea. RAG is not a research prototype. It's running in production everywhere you look. Customer support chatbots use it to answer questions from product documentation. Legal research tools use it to find relevant case law and statutes. Medical AI systems use it to ground diagnoses in published literature. Even code assistants use it to search your codebase and answer questions about your own repositories. The pattern is always the same: retrieve the relevant context, then generate the answer. And here's the best part, the tools are free and open source. Chroma for vector storage. Face for similarity search. LangChain and Llama Index to wire everything together. You don't need a PhD. You don't need a data center. You can build a RAG system this weekend on your laptop. Let's bring this together. Large language models are not databases. They don't look up facts, they predict words. Which means that sometimes, they make things up. RAG fixes this by giving the model a search engine for your own documents. Embeddings turn text into meaning. Vector search finds the right chunks in milliseconds. And the generation step produces an answer grounded in real sources, not training data memories. The keyword is retrieval. Stop asking models to remember. Give them the ability to look things up. Next episode, we're going to flip the script entirely. Instead of teaching AI to follow instructions, we're going to look at how AI teaches itself, the story of reinforcement learning and why it's producing the most capable models we've ever seen. Subscribe so you don't miss it.